Hello, everyone. Welcome to our presentation on predicting customer credit card attrition. This project was undertaken as part of our data analytics course at the Budapest University of Technology and Economics. Our goal was to explore how machine learning can be leveraged to identify customers who are likely to stop using their credit cards, allowing banks to intervene in time. The team members who contributed to this project are listed here, and we are grateful for the guidance of our instructor, Anna Ernesto Takats. Customer churn or attrition is a critical problem in the financial services industry. Every customer that leaves represents a lost opportunity for revenue and potentially an increased cost of acquisition to replace them. Traditionally, identifying at-risk customers has relied on manual analysis, which is not only time-consuming but also inefficient given the volume of customer data available. Our aim with this project was to create a machine learning-based system that can predict customer churn accurately and support banks in implementing timely and proactive retention strategies. The data used for our analysis comes from Kaggle and is referred to as the bank journals dataset. Initially, it included 10,127 records and 23 features. After pre-processing, we had a clean datasheet with 10,013 entries and 22 useful features. These features span customer demographics such as age, gender, income, as well as behavioral data like transaction amounts, credit limits, and account history. Understanding these features helped us define our modeling strategy and provided insights into what might trigger customer churn. Before diving into modeling, we prepared the data using several pre-processing steps. We dropped non-predictive attributes like client name and removed records with unknown values in critical fields such as education level and marital status. Next, we encoded categorical behavior Next, we included categorical variables and normalized numerical ones to ensure consistent model behavior. Finally, we split the data into training 70% and test 30% sets. These steps were crucial to reduce noise and bias, setting a solid foundation for building reliable machine learning models. For our primary predictive model, we chose logistic regression. This model is highly suitable for binary classification problems like ours, where the output is either churn or no churn. We can support this statement from our literature review as well, as almost all of the authors chose to do so. Logistic regression offers a good balance of accuracy, interpretability, and resistance to overfitting, which is especially important since the treated customers represent a minority in our dataset. Another advantage is that it provides probability scores, which allows businesses to adjust the prediction threshold based on their operational priorities. Now, my next event is going to assist. Thank you.
Continuing with the modeling, we didn't just stop at one model. We used Rapid's minor auto model, and we also evaluated other classification algorithms such as the random forest and decision trees. And this model was tested on the same data we use, so the training and the test sets. And the results from the auto model confirmed that the regression performed really well in terms of its performance metrics. So you have items like recall, you have variation, and also in terms of interpretability. However, we have ensemble methods like random forest, which also have strong performance and could also be considered if we wanted to explore this further. So as part of our exploratory data analysis, we discovered some key trends. First of all, was that most customers who churned were within the 40 to 55 age group. We also discovered a key class imbalance. So the proportion of the customer who churned, so the attrition customers, were quite low compared to the customers who are retained, so the existing customers. And this imbalance essentially emphasized that we needed to focus on a model that can actually be able to account for this imbalance and ensure that we have as fewer customer channels as possible without compromising its accuracy. Also, as part of our data exploration, we did some visualization, and this actually helped us understand more about the customer behavior. First of all, was that customers with higher income levels are less likely to churn. So as you can see from the graph on your far right, also we discovered some linear relationships based on the correlation matrix that you can see below. And specifically, we discovered that one attribute, so the naive Bayes classifier, as you can see down on the bottom right, has a very high weight when it comes into the linear relationship with our dependent variable. So this is something we hope to investigate more when doing our analysis. And also this could be part of something that informs our predictive analysis upon the next phase. My colleague will continue.
Our logistic regression model achieved higher performance matrices, in particularly for recall and the attrition class. This is a critical because false negative failing to identify actual churners can be costly for a business. Their confusion metrics confirm low false negatives and acceptable false positives. Interestingly, one attribute related to knife bias classifier received an unusually high weightage. This raised question about its real-world applicability and indicates a need for validation before the live deployment. From a business standpoint, the model has critical implication. It enables real-time churn prediction, allowing banks to implement targeted engagement strategies like personalized offer or proactive communication. However, to deploy it effectively, the model needs access to real-time data. All consumption must be tested with live customer data. The ability to act quickly and accurately can significantly improve retention and customer satisfaction. So to summarize, we can say that our goal was to predict credit card attrition using machine learning. We performed throughout data cleaning, visualization, and modeling using logistic regression. The model performed well and provided actionable insights. Looking ahead, we recommend deploying the model in a pilot environment and enhance it with dynamic data feeds to improve its robustness and real-time applicability. We would like to acknowledge the functional fundamental research that supported our methodology. These included recent studies by Wang and Chen, Nandini et al., Chen, and others who have explored machine learning for customer churn prediction in depth. Their insight helped us structure our approach and validate our findings properly. So, thank you for your attention. We hope to see you in the defense. Thank you.